In this video, we are going to be looking at quadratic equations, and at the end of this video, students should be able to define what quadratic equation is and should be able to solve problems involving quadratic equations. So when we speak of quadratic equation, we are speaking of an equation of this form. We are speaking of an equation of this form where we have ax squared plus bx plus c equal to 0. So when we speak of quadratic equation, we are referring to equation of this form where a, b and c are the constants, and a is not equal to 0, right? A cannot be equal to 0 here, and then otherwise the equation becomes a linear, because this is what makes it quadratic. The square is what makes it quadratic, which means it's of degree 2, right? Which means it's of polynomial of degree 2. So it's the square that makes it quadratic. So if we remove this square from here, what we have is just bx plus c equal to 0, which is a linear equation. So this is our general form of a quadratic equation. So quickly, let's look at solution of quadratic equation. We say that this is the form of our quadratic equation, and this is solved to get this x, the value of x. If we make x the subject of the formula in this situation, this is where we are going to resort to. And then I would like us to prove that very quickly by using method of completing the square method. So to solve this, we have the general form to be ax squared plus bx plus c equal to 0. So let's divide all through by a. We're going to have b over a x plus c over a equal to 0. So that's what we have. Now let us add half of b over a squared to both sides of the equation. Now, whereas we can move this to the other side, x squared plus b over ax equal to minus c over a, right? So let us add this to both sides of the equation. So if we add this to both sides of the equation, we are going to have x squared. We are going to have x squared plus b over a x plus 1 over 2 b over a squared, right, equal to minus c over a plus 1 over 2 b over a squared. So this now is an expansion of this form, x plus b over 2a squared. This left hand side, the expansion of this form. If we open this bracket, if we expand this, we are going to resolve to the left hand side. So we can just factorize it to this form, and we equate it to minus 2 over a plus, we could say this is b squared over 4 a squared, right? We can write it this way, b squared over 4 a squared. So if we have something like this, what else can we do? If we have something like this, let's take the square root of both sides, so that we are trying to make x the subject of the formula. So let's take square root of both sides. So if we take square root of both sides, we're going to have x plus b over 2a to be equal to the square root, right, of minus c over 4a plus b squared over 4a squared. So this is what we have. So which means this can also be broken down. X plus b over 2a is going to be equal to square root. It's going to be equal to square root of let's find the LCM of this. The LCM of this, we have it to be 4a squared. So if the LCM is 4a squared, a will go into 4a squared 4a times. So we have minus 4ac, right? Then plus b squared, right? Let me change the ink. So here we are going to have x. So we are going to have this to be minus b over 2a, right? Then plus, now we have 4a squared here, which means we can actually find the square root, which we are going to be left with minus 4 square root of minus 4 ac plus b squared divided by 2a, right? This is getting more interesting. Divided by 2a. So from here we are going to have x. X is going to be equal to what? This is the same denominator, so we have minus b plus square root b squared minus 4ac all divided by 2a. Now in terms of quadratic equation, remember we are going to have two answers, right? Our answer is going to have two parts, so we are going to put plus or minus, because our answer is going to be either plus or minus, right? So that is why we normally put the plus and minus here, plus or and minus here all together, right? So this have proved this, right? If you check this and you see this, they are the same thing. So this is how to prove this equation where x is either this or x is this. So we are going to be using this formula to solve a lot of questions involving quadratic equations.